episode of FUM0021 machine, we are going to talk about the VFD modulator. More precisely, we are going to talk about the printed circuit board. Namely, I have one here. Well, I put a larger picture there. And we are going to go through this board. Why is it set up as it is? That's one. How it is set up as it is. And furthermore, we are going to go through some of the components, the component types, how to get them, how to solder them into this circuit board. Well, let's go on with it. In order to get the PCB boards, I had to fetch them from customs. This time the customs was located behind the airport, and it was something like 20 kilometers there. Well, it was a good time for some bicycling practice. Well, despite the somewhat rainy and windy weather, this creature made me happy. It always does. This is something you need to be aware of if it is raining a lot. This is a drainage channel. Sometimes the scenery was really ugly. All you needed to do was to turn your head, and it was no more ugly. Well, this was a really scary installation. It was quite near and made awful sounds. Holding the camera and driving a bike. Well, I cannot do this. So, this is the printed circuit board for this VFD. Well, as every PCB, this one has two sides. First of all, the back side, and then or underside, and then the top side. There is a huge difference between these sides. The bottom side is void of any components. Yes, it's no components here. And of course, all the components are on the top side. Well, this is one thing which is really important. When you solder these components in this printed circuit board, you could use a method called warming. So you put this PCB on a warm plate, and then you just warm it up until the solder melts. That's basically it. In this method, which I'm going to discuss a little bit later, you use a special paste, etc. Okay. Now, because we don't have any components on the back side, it's very, I mean very easy to warm this up, because you don't need to worry about any thing that could happen for the backside. Okay, that's one thing about this. A major difference between the sides. And then on each corner we have this, well, it's just a place for fastener. And if you look the backside, you can see that we have the same things here. And if you look very carefully, I put on, well, maybe you can see it here, but I put an enlarged portion of this place here. These are totally isolated from the rest of the circuit, so you can use fasteners and you don't need to worry about short-circuiting anything. And furthermore, you can, and you should actually, you can solder a washer here. This is prepared in a way that you can solder a washer here on both sides. This material tolerates a lot of squeezing, but it does not tolerate a lot of bending, and if the surface area of the screw is very small, it can actually damage the board. So if you really want to put this hard somewhere, so you solder a washer on each corner on both sides. It's really easy to do, and after that it will it's wonderful. Okay. And then if you look into this board, you can see that there are places here a little bit bigger, these circles here. These are meant to be a through-hole component, which is a connector. And same thing here. There are actually two connectors on each side. Each side has one connector, two connectors all together. And this side here goes to, which way should I draw this? Well, VFD. Hopefully this is correct now. Can you see it? No, you cannot see it. Okay, this side connects. No, this is horrible. Okay, VFD, and VFD. Okay, and this one goes to your knobs and controls, etc. Here you have 3 inputs for your potentiometers, 3 inputs for your knobs, and then you have the ground, and then, no, this one is the +5, and this one is your ground. And same here, you have 4 connections for the VFD control, the knobs, start, stop, reverse, and etc., whatever you need. And then you have one, this one is the voltage, which controls the VFD speed. Then you have the plus in, and then you have 2 couples of ground here. One is the actual ground wire, which runs all the way to the VFD ground, and the other one is for the shielding of the cable, and it shouldn't be connected, it should only be connected on this side, not on the on the VFD side. You should not connect it there anywhere. Just leave it hanging on the other end. It's a mistake to use the shielding as ground. It should be shielding, not a ground. And then we have a bunch of components all over in between. The first, the biggest component of them all is going to be here. It's an inductor, which is coming directly from the plus here, and then you filter out the plus 12 volts with that inductor, and then you have here a capacitor. It's a specific called OSCON, and this one has a very low effective series resistance. Furthermore, in these three pads are for 5-volt regulator. And then here comes the programming interface. Here is some watchdog circuitry, these things that control the reset signal. And then we have here an dual operational amplifier, which is taking care of the filtering of the PWM signal. These four guys here, these very small pads here, these are the four FETs acting as buttons for the VFD. And then they have some resistors, etc. Then we have furthermore the analog side, which is here. We have the analog VCC. Analog needs its own supply. There will be a very small inductor here. Some bypass capacitors for the supply and the reference voltage. And then we have the three series resistances from the potentiometers and the bypass capacitors. That's about it. And furthermore, we have these button inputs here, 3 of these, and they are pull-up resistors. So if you don't put a button there, it will act as no button, as nobody had pushed the button. And then we have a bunch of bypass capacitors all over the plate. Well, let's go now into details of all the components used in here. Actually, I'm not back at home, so I don't have the actual components. So I need to search internet for pictures of those. Sorry about that. I don't like it myself either, but it's the only chance at the moment. And then I'm talking for each component, I'm talking about their special requirements for soldering, etc. This will be the next thing we talk about. This is my virtual workshop. We are going to construct this VFD modulator in a virtual way. Of course, this needs to be constructed in real life as well. So, therefore, first thing, let's go through the tools we are going to need to construct this one. First of all, we need a table. There, a table. This table, well, it doesn't need to be. Your workshop table might be okay. Well, then you need to hold this PCB somehow. Well, or you don't. Just put it on the table, because it has the components only on the other side. It's very easy. What I usually do, I put some tape around under, double-sided tape, so it holds in place, doesn't move around. Okay. Then, because these components are really small, really small, you need tweezers like that. Those. These tweezers need to be very sharp, very small. Back home I have one that is, those are made of stainless steel, and another pair which is made from titanium. And those are really nice because titanium doesn't wet with any kind of solder. So you can pick up and it doesn't get contaminated. The stainless steel, sometimes you get something horrible into that. Next thing, you are a tool, a very important tool you need for this operation is some sort of magnifying glass. Again, the components are really small and you need that. I need, my eyes are old and I don't need reading glasses, but yet these components are really small. The next thing you are going to need is some sort of soldering iron. Well, for these small components you cannot do this with 100 watt part L like that. You need something like that. That's an Antex soldering station. I have, well, because electronics is or has and is my hobby for very long time. So therefore I do have a soldering station like that. It's something that is really expensive. If you do this once in a lifetime, don't bother. This is not for you. You are well off with something like the Antex. It's not too expensive and it's still usable. But what you need are very tiny soldering bits, something like 1 millimeter. Well, you can get, you can do it with larger, but the smaller the better. The Metcal I do have, that is a Metcal. Is very specific. It heats the tip with radio frequency, and all the power is on the tip, and you can hold the tool very near your soldering point. So this makes it very easy to use. Antex has something like 5 centimeters. It's a bit long, but you can still use that one. Okay. Well, and then you need some lead. Tin. Soldering tin. Soldering whatever. This needs to be really thin. Back home I have 0.3 millimeters. Then I have 1/2 millimeter, and then I have something that is 1 millimeter in diameter. The 1 millimeter in diameter is way too large for this operation. You need very small. Yes. Okay. That's about the tools. I will probably make another video about the tools. So now let's bring in the board. There is our board, and well, looks nice, doesn't it? And now when we install components into this board, it's better to start from the least sensitive components. That's a definite mistake to put the microcontroller there first, and all the semiconductors. They are really sensitive and or might be sensitive, and you might end up destroying some of them. So therefore, let's start with the least sensitive components, which are in this case the resistors. This is a size 05, 08 or whatever, really small, and well, you need the magnifying glass, your tweezers, and then you what I usually do, I take one resistor. I take it. And then I put a little bit of solder on the PCB, and then solder it from the other end. And then, because now it's attached to the PCB, the other end is really easy. Well, because I have a hot air reworking station, I usually finalize the job with that one, so it becomes, it looks nice and whatever. But you can also get rid of, you can get it working without this hot air thing. Okay, once you have all the resistors in place, are they all? Yeah. Then the next least sensitive component is, or are, the capacitors. In this case we are using ceramic SMD, surface mount device capacitors, and the soldering technique is quite the same. You first solder the other end and then the other end. Yeah. So here are the capacitors. They are well. One thing about the capacitors are that you cannot know what's the value because it's not printed on the component. So once you mix them up, you are basically screwed. You can measure it, but it's very good practice not to mix them up before installing in the plate. So let's install them in the plate. Poof! Box! There they are. Now we have the resistors and capacitors on place. Next thing will be what's the next least sensitive thing? It's the inductors. They are not really sensitive at all. So let's put them there. Books and books. Well, yeah. You can buy these. You can put them in any order you like, but I usually put the smaller ones first and then the larger ones. Just a habit. Then, now we have resistors, capacitors and the inductors on the plate. Well, next thing will be, let's put the FETs there. Okay, we have 4 couples of 2N7002 type of FETs, and then we have one which they are all in a similar package. This is SO23. It's a very small transistor with it's like a transistor. The power supply watcher is an IC, very complicated inside, and then we have these ordinary MOSFETs. Well, let's put them in plate. There you are. Okay. Next thing, I would put as the next thing now the microcontroller. It's this one is a little bit more complicated to put on your plate. If you don't have very thin solder, you need to use a lot of flux. But since I have this very thin solder, I can I can put it in place quite easily. But you have to be really careful to put it in correct orientation. You can put this, there is a 25% chance to put it correct. 1 of 4. Okay. There is a small dot in one corner of this device. So take care where to put that dot. It's really I have been soldering these on and off a few times because I didn't pay enough attention to this small but still very important thing. Okay, once it's in place, you are quite done. And then the rest of the components are like the connector. This is the programming connector. It's an pin header, 6 pins. You can do without this one if you want. Then we need the regulator. That's the regulator. Yeah. And finally, not finally, but we need what is still missing. I need to remember. Empty places in the there. OSCON. This is the filtering capacitor. We need that. You can do with ordinary capacitor if you want. Just put something like 100 microfarads there, and you are good to go. Well, hopefully I didn't forget any components because I didn't watch the video while I did it. I just recorded this nice speech. And yeah, I will put some text behind if needed. So, okay, we have now virtually constructed this VFD modulator. Well, this was the presentation of the printed circuit board. In the next episode, we are going to do some programming. Yes, we are going to do some programming. And this should be fun for some of you. Well, till then, see you!